Thank you.
Yeah, we can start now, Iman.
Yeah, sure. Thanks, Ajit. Good evening, everyone. Welcome again to our third CPD for 2024. I'm Iman Abisab. I'm the chair of the iStruct UAE Regional Group. Our talk today will be recorded and uploaded to YouTube on YouTube for your future reference. We have our sponsor, Hempel, who is a supplier of intermittent durability and fireproof coating for steelwork. And I'm happy to introduce our speaker tonight, Engineer Chirag Baxi. Chirag is a general manager of Accord Specialities Contracting. And Chirag will be presenting tonight on the structural corrosion of concrete and steel. And I think we all agree that understanding the causes of corrosions and associated protection and repair mechanism help to preserve our assets, ensure longevity, safety, and of course, minimize costly repairs. So I hope this session will be useful to everyone in this regard. And a bit of background on Chirag, just before we start. Chirag is a civil engineer with over 40 years of postgraduate experience, out of which 20 years were focused on the corrosion protection of concrete and steel and rehabilitation. Chirag holds a master's degree in construction management. He specializes in the industrial sector with particular interest in the corrosion from chemical attack. Chirag has authored 2 books entitled Concrete and Steel Structure Engineering for Cure and another book entitled Sustainable Construction Practices. He has presented more than 65 technical papers on the subject of his core competencies. And Chirag is a member of the Bureau of Indian Standards. He's a member of the committee that's reviewing Indian standards and also has drafted Indian standard codes. Chirag, perhaps an interesting one to add, which is quite unique, is that Chirag is a gifted author who has published a book entitled Values and Ethics, Wheels of Life, as well as a romantic novel entitled Love at Mid-Sea. So I really intentionally mentioned that. I think it's quite interesting, Chirag. So great, and I'll be looking forward to look for these novels particularly. Chirag has also acted in a few short films. Okay, now back to structural corrosion. And before I hand over to you, Chirag, I'd like to, if I may ask you all to keep your questions in the chat box till the end. You can ask them live or we can ask them for you. That's all, basically. Over to you, Chirag, to start the session. Thank you.
Thank you very much, ma'am, Imam. Greetings from Chirag. I first of all thank iStruct management to give me the opportunity to share my applied knowledge from this August platform. I introduce our organization in a very brief manner. We are Accord Group, led by technocrat, stalwart, dynamic duo of Mr. Jay Prakash, we call him JP, and Mr. Imtiaz. I am general manager in Accord Specialities. The domain of Accord Specialities covers structural damage assessment for concrete and steel, structural rehabilitation for concrete structures, crack repair, water leakage arresting, structural strengthening with CFRP matrices, corrosion control measures for concrete and steel, and in industries also we have put our fingers on. So with that, we are Accord Group, and with that we start the work, we start the talk. Basically, we are going to be talking about concrete. Before we go to real slides, I will request all of you to start from today to maybe a big takeaway for you. Concrete is a live entity. It is not a dead element. It's a live entity. It reacts. It breathes. It reacts. It smiles. It agonizes. It bleeds. it gets cancer, as it was said in the beginning. It also dies. But we don't want concrete to die. It has been helping the construction industry for about more than 2 centuries, and we have reached a stage wherein we are making the concrete sustainable one. So we want the concrete to be sustainable, and for that we want the measures to make it sustainable. How do we make the concrete sustainable? There are, according to me, there are fundamental essentials which make concrete sustainable, as we see in the next slide. Concrete is alkaline. When I go for a lecture in classrooms in a university, I always ask students, "Or what is the pH of concrete?" But it is not the right question at this platform. So alkalinity of concrete must be maintained right up to its full curing period, or even more than that, for the whole functional life of concrete member. So alkalinity is the basic nature of concrete, basic element of basic phenomena of concrete, and that must be maintained. If it is disturbed, we are towards its end. Second is, all efforts should be deployed to bring the porosity to zero, near to zero. We all know that concrete it is impossible to manufacture impervious concrete. That's fine. But then if porosity is brought close to zero, then there are very, very few possibilities of contaminants entering the concrete mass and spoiling the concrete. So this is the second essential thing which should be done to make sustainable concrete, or concrete sustainable. Third is resistance to chloride. Chloride and sulfates are the strongest enemies for contaminants for concrete to corrode. So chloride resistance to chloride must be ensured right at wet stage as well as hardened stage. We should not leave any chloride containing element even at wet stage, so that it continues to be at hardened stage, and at hardened stage it develops the damage. Refer ASTM C117. And the fourth one, most important, is reinforcement corrosion should be brought to no possibility of corrosion. That is what a term has been used in STM G109, and that is where we must try to see that no contaminants or no element, no conditions lead the reinforcement corrosion to reinforcement to corrosion stage. So reinforcement corrosion should be minimized, should be mitigated, and the versatile concrete should be manufactured to ensure all these things right at the beginning manufacturing stage, so that we ensure that whatever we manufactured concrete is sustainable and it is not going to deteriorate and maybe going to some rehabilitation area. Concrete has got some limitations. Concrete is ultimately man-made material, and it has got some limitations. So alkalinity and so many other things, and we design. But then concrete has got limitations, and we must be able to identify those limitations, and we must be able to ensure that concrete is not exposed to those challenging conditions, so that it starts deteriorating and starts getting corroded. Factors which affect sustainability are being discussed now. Concrete corrosion. Okay, what is concrete corrosion? We are much aware of steel corrosion, rust product, and orange product, and Fe2O3 and Fe3O4 and FeO and all those things. But what is concrete corrosion? Concrete corrosion, as per my definition, as my applied knowledge goes, is a phenomena under which the ingredients of concrete are depolarized to go to heterogeneity. There are few factors. There are quite many factors which depolarize concrete. The homogeneity of concrete goes away. That can happen only when cementitious binding actions start getting away. So that is concrete corrosion, according to me. And by grace of God, it has been agreed by so many platforms, so many areas. So this is what I would like to define as concrete corrosion. Efflorescence emerging out of concrete member is one of the significant signs of concrete corrosions. Observations like honeycomb structure and spoiling of concrete, etc., are the effects of concrete corrosion. So concrete corrosion can be seen when we see efflorescence coming out, when we see this There's some signs, some honeycomb signs, and some spalling. Spalling is a later stage, but then when we see these type of things, then we have to be alert. We have to be on our toes to see that it doesn't propagate further. Conditions which cause concrete corrosion are now being discussed now. High humidity. When concrete is exposed to very high humidity, wherein it cannot function well, it cannot breathe well, it cannot have equilibrium between inner humidity and external humidity, then concrete starts corroding. High temperature also is a factor which corrodes concrete. We will see effect of high temperature in one of the slides in later part of the presentation. What high temperature can do to concrete structure, concrete matrix, that is also one of the important factors. Saline conditions, as we all know in UAE and in GCC by and large, we have saline conditions. So salinity, so salty conditions, they cause corrosion. They start penetrating inside the concrete core. They have hygroscopicity within as a nature, and that's how it helps them to enter the concrete mass. That starts reinforcement corrosion. If by any chance we have left any contaminant or left anything which is close to reinforcement steel, then it will start corroding. That also it will be the beginning of concrete corrosion too. Sometimes we are all structural engineers. Sometimes design inadequacy. I have seen in this part of the world that design inadequacy emerges out of some deficiency, some sign, some effect, some crack from a blue corner, which ultimately, when analyzed, it goes down to design deficiency. And it may not be failure, but then it is a concrete corrosion, the beginning of concrete corrosion. Design deficiency also can lead to that. Chemical environment. I have industrial background, so chemical environment, I've been talking a lot on that, but then this is not the right platform to talk on industrial background. So I'll just touch upon one point: gaseous, liquid, or solid chemicals coming in contact with concrete. I can spend 2 hours on that, but then these chemicals are potential source of concrete corrosion. Bird dropping. Now you will be surprised to know what is bird dropping. The undigested stuff in bird dropping, it leads to a terrace garden, or the next slide I'm going to show that. Can you see? You must have seen so many of such type of things. From where from this plant has come up in the window jams. It has come up only because of bird dropping, and these plants have deep roots, and when deep rooted things, they start penetrating inside the concrete core. It starts eating away the concrete matrix, and that's how the cracks are developed, and that again is the beginning of the end. Substandard construction practices, I don't want to talk much about that. There are many practices which have to be maintained as per the standards laid down in all parts of the world. But then sometimes substandard practices, it comes out during the NDT analysis. When we analyze the structure, and when we correlate the NDT results, then sometimes it comes out that there was no reason for concrete member to fail or to get corroded. But then substandard practices, it emerges out at that level. I have seen that in my analysis. There are forced compromises because of financial controls. My budget was $2,000, and I was asked to do it in $1,500 or $1,850. So where do I cut down my $150? I do not know. Inadvertently, unknowingly, I would compromise somewhere on the quality, and that may bring me down to the concrete corrosion stage. Lack of maintenance. Concrete structures must be maintained whenever they're exposed to. They may be exposed to saline conditions, or UV attack, or humidity, or wherever. But then they must be regularly maintained. They must be inspected regularly and maintained regularly, so that a stitch in time saves 9. It's a proverb in English. A stitch in time saves 9. So if you take a corrective action at the right time, you don't have to enter into a big chaos. Failure of concealed services. I don't know how many of you have seen electrical conduits in roof area carrying water. I don't know how many of you have seen. How many of you have seen the rusty water within home pipelines? So sometimes it happens. So concealed services, when they fail, they also carry the material which is not supposed to be carried by them, and that's where it also can cause concrete corrosion. Improper construction materials also is one of the factors. If you have to use PVC pipes and if you use metallic pipes, you are liable to go for rusting, water leakage, and leaking water entering concrete core may corrode concrete. So they may have indirect effects, but then they have effects. Unforeseen natural calamity, of course, it's not in our hands, like act of God, like blast or flood or fire or earthquake or all those things. Ultimately, they have after effects of concrete corrosion. So they cannot be ignored. But anyway, it's not in our hands. So we have to accept them and we have to adjust to them. Stagnation of corrosive chemicals. Sometimes, I mean, I don't want to name them, but there are some areas where even in few public places, sometimes corrosive chemicals get stagnated, and that's where they can also eat away concrete. That is very dangerous. So these are few factors which can corrode concrete, and these are few factors from which concrete has to be protected. Why do we have woolen wears in winter? Why do we have raincoats in monsoon? That is to protect our body. And concrete, as I said in the beginning, must be essentially considered as a lively element. It is not a dead element. So concrete also needs protection. So that is why it has to be protected from all these conditions. What happens as concrete corrosion? Loss of integrity, as I said earlier, heterogeneity, homogeneity is lost. Strength is lost, of course. Stability and soundness of the member also gets affected. The members goes to unsafe zone for load sharing phenomena for which it was designed previously, maybe column, maybe a beam, maybe a slab, maybe foundation, maybe any structure. But then that thing has to be, it will start losing its stability. Necessity of reconstruction of member causing environmental issues and economical issue. Of course, ultimately it costs money. So that has to be seen that we have to minimize the reinforcement corrosion. Measures to mitigate concrete corrosion. How can we mitigate concrete corrosion? Before I go further, I must tell you that 4 things which I said earlier, they give internal immunity to concrete member. As we have internal immunity for our body, we take vitamins and we take some supportive medicine, some supportive immunity boost up doses, so that we have internal immunity, internal strength to resist, to fight out against any decisive condition. Those 4 conditions are imparting in internal immunity to concrete structures. So that must be there. In addition, the external factors which can protect concrete are being discussed now. It is said prevention is better than cure. Definitely, prevention has to be done. So prevention is discussed in those 4 points. However, effective protection can definitely prevent from deterioration. Mitigating concrete corrosion can be based in effectively protecting concrete. Then carrying causing corrosion. The treatment which have been standardized are being discussed now. Now, in this also, the industries have different scenario. Industrial scenario is totally different from what I'm going to talk now, because industrial scenario needs some acid proofing treatment and some ties and some bricks and some stones and some epoxies and some vinyl esters and polyesters and some sheets and all those things. But they are not being discussed now because we are not into industrial area. So we'll talk about what are the conventional things to be taken care of. These are the criteria of selecting the material for protecting concrete. It should have inertness, zero reactivity to the material causing or conditions causing corrosion. Thermal coefficient of expansion and contraction is very important. Suppose if we apply that particular treatment, which is not having same or similar or close thermal coefficient of expansion and contraction to concrete surface, then both are going to behave differently, and we do not know how that bond will be carried unless the elastomericidity is very prompt. Exothermic properties, when we really think of resinous materials, epoxy-based material, then exothermic properties also matter a lot in selecting this type of coatings. Compatibility of material, as we said earlier, there may be combination of conditions. Sometimes there may be salinity as well as UV attack. In this part of the world, we see saline attack, some structures standing in front of sea. They also face UV attack of sunlight, and then they say salinity. So when combined attacks are there, then the compatibility of the coating material should be such that it resists both conditions effectively. Economics, of course, everything ultimately ends up on economy. So economical aspects must be taken care. And here I have added one point, that is functional life. What exact functional life we expect from that coating, or if we expect from that member? If it is more, then the treatment can be commensurate with that particular life expectancy, rather than we go for go gold plating the things, and we want the structure to live only for 2 years. That may not be required, right? The nature of damage caused by corrosive condition, that also must be seen. What UV attack will do, what the salinity will do, what thermal things will do, what my humidity will do. All those things must be taken care, and that is how the thing must be decided. It should be tailor-made system. Improving ventilation and effective draining, and all these are all parameters which can support. In addition to thermal, the external treatment, these things can support mitigating the corrosion. Protective coating to effectively resist the conditions causing corrosion are basic fundamental requirements to prevent. So protective coating, usually these protective coatings are not usually cosmetic coatings. Cosmetic coatings might have some different functionality. They go on gloss retention, and they go on beauty retention and all those things. But then protective coatings may not have that cosmetic value, and should not have. I mean, they may not also have. Protective coatings are different cosmetic, as I said earlier. Polymeric coatings are protective coatings. Resinous coatings are protective coatings. Modified acrylic coatings are protective coatings. Anti-carbonation are protective coatings. So there are few. These are the 4 types, which, as I said, there may be many more. There may be integrated protective coating, which may have to be designed as per the condition prevailing, or condition to which the member is exposed to. So that is most important. It should be tailor-made. It should not be just, copy-paste doesn't work here. So it should be tailor-made. This is one of the protective coatings at the floor. You might have seen in dust-free rooms or IT rooms or operation theaters. These type of things are done. So they are for different functionality. Okay. Even after all these things, suppose if concrete starts getting corroded, suppose if concrete starts getting deteriorated, and the concrete has something has to be done. So then we have to become pathologist first, and then doctor. So pathologist, what all they'll do non-testing of the concrete. So non-destructive testing is done first of all to see the extent of damage, the root cause of damage, the severity of damage, and combining all those things, the analysis at the end of the day, preferably with forensic engineering approach, that can lead us to the right scheme which is suitable for that for retrofitting of that particular deteriorated member to bring the functional life to the desired one. In spite of this, as I said earlier, actions begin with testing of the thing. Once it is identified, these are the signs: cracks and efflorescence and honeycomb and erosion, skin erosion, reinforcement exposure, etc. These are the signs which lead us to the belief that concrete is start deteriorating. this is the sequence which is followed to bring the concrete to normal condition: damage assessment, analyzing the entity results, designing the tailor-made. I said tailor-made scheme is very important. That's for rehab, execution of sting, and repeat NDTs. The NDTs revealed that structure was deteriorated, and it also quantified the damage potential. So repeat NDTs to ensure that the structure has been retrofitted well. Doctor had put thermometer in my mouth to see. I had the fever of 104°F, and then after I was cured, he again put that thermometer to see that my temperature was normal. So that is what should be done, and it should be repeated. Damaged concrete must be tested with non-destructive method. Because why non-destructive? Why non-destructive? Because concrete is already damaged, yeah. The concrete is damaged. Why do we want to go for again destruction? Why do we want to again core extraction, and why do we want to again damage? Go for NDT method. There are many NDT methods available in the world by now, so which can take you close to the root cause of damage. These are the mostly used NDT methods. Are these? There are many more: rebound hammer, ultrasound pulse velocity, and carbonation, and upsell potential test, chemical analysis, sulfur chloride content. RCPT is one of the tests which is not regularly done, but then to find out the chloride potential penetration in hardened concrete, this test is being done. Rebar locator test, thermography test. Thermography test used to be done only on steel structures, but then these days it has been brought to concrete structures also. And I have written a draft IS code, Indian Standard Code, for this particular test for in India. Core compressive test, destructive test, which I am not advocating much of. We'll run through quickly rebound hammer test. This is a rebound hammer. It's very easy. Surface hardness, the resistance offered by the spring for the surface hardness, it measures rebound index, and it can be done in calibration. So let us run quickly. This is pulse velocity test. This is done in three manners. One is direct method, one is semi-direct method, and third is indirect method. The sound waves are emitted from one point and received at one point, and the time taken to travel that sound wave from one point to other point is calculated, and then divided by the distance travel gives you velocity. More the velocity, what is it? What is it? More the velocity, good concrete. Less velocity, bad concrete. This is where people have a lot of misconceptions. Why more velocity and why less velocity and all those things. So more velocity has got good concrete. So I'll go through quickly. These are three methods, and all these things, transfer, shear. These are the values as per the Indian standard. Velocity and the condition, it has been said. Carbonation is a test wherein carbonation effects are there. We all know about it. Phenolphthalein spot is put, and when the color doesn't change, then the concrete is carbonated, and when it changes, it is not carbonated. This is what has been said. Upsell potential test. This is the potential difference measurement between one end of the reinforcement bar and other end of the voltmeter, to identify what is the resistance offered, additional resistance offered by the corrosion product, and that brings you close to the reinforcement corrosion area. That this is how it works. It's a philosophy. It works with this. The method is there. ASTMC 876 also gives a standard test method for this. Chemical analysis, as I said, chloride and sulfates are the most dangerous contaminants for concrete, so they must be tested. Chemical analysis, pH is being tested. Then sulfate content test is done. Chloride content test also is done in a similar manner. Conditions causing steel structure corrosion. I also have to cover steel structure. Steel structure also is getting corroded, but the steel structure, how, under which conditions steel structure also will get corroded, it is more relevant with industrial area, but then we must know this. So that's why I'm bringing to your kind notice. Corrosive fumes or splash. Unprecedented stresses generated within structure. Now, this is very important. Unprecedented stresses. Stress is a stress corrosion, and stress corrosion takes place. It is very significant. High humidity or high temperature. Modification of functionality. The structure was designed to support a mall sort of culture, and one day you start producing soda ash in that. So what will happen? It will start corroding. So when you change functionality, that also will corrode things. Resultant effects of steel are seen in generation of rust. Steel structures get damaged due to exposure of corrosive conditions. First parameter affected to be, I think, section thickness is being reduced. Usually, in my I've seen in the last 4 decades, usually in my that to reduce 1 millimeter of thickness of a steel member, it takes about 1 year in normal corrosive condition, and it takes only 8 months in severe conditions. That is important. It doesn't, I mean, no book or no code will say that, but my experience says that. That's what I shared with you. Second parameter to be affected is microstructure. Now here I'll show you some very beautiful thing. Microstructure, how microstructure gets affected with corrosion. I'll show you this. Tests to be done are section thickness and microstructure and thermography and metallurgical. All those analyses are to be done for steel structure. Now, thickness of metal structure, of course, it is thickness measurement. It is just like USPV measurement. This is what I want to share with you with some discussion. Microstructure is the one thing where 750 times enlargement picture is taken with X-ray sort of arrangement, and you can see the microstructure without any deterioration in this slide. I don't know where the slide is gone. Oh, sorry, slide. I'm not able to show the slide, but there are microstructures which have fissures. The fissures and fissure, during the fissure, the contaminant has gone and settled inside the fissure. I'll try to share. I don't know why slide is not coming, but that is what I wanted to show with you. That is very important, you know. Then, okay, coming back to concrete, when concrete has deteriorated, NDT has been done. Now we have to cure the concrete. So now pathology role is over. Now the role of doctor starts. We have to assume the role of doctor. Damage assessment was done. Now this is where I want to spend some time with you. Results of NDT have to be comprehensively analyzed. Very, very important. You cannot rely on one result of NDT. You cannot rely on rebound hammer. You cannot rely only on USPV. You cannot rely only on Hubschel potential test. You cannot rely only on RCPT tests or thermography tests. All results have to be seen simultaneously, comprehensively, because every result, every parameter, every result represents every parameter. And every parameter has got influence on each other parameter. All parameters are interlinked with each other. If porosity is there, identified under USPV, and if reinforcement corrosion identified, I do not know whether strength was bad or not. If strength was good and reinforcement corrosion was there, then USPV was bad or what? So we have to identify whether concrete mass is bad, whether reinforcement is bad, or whether some practices were bad, or whether some contamination still present in the concrete, or still there is something settled within the concrete. I mean, we have to identify. So it is very, very important, it is mandatory. It is a holistic requirement that all NDT results have to be very comprehensively evaluated, and preferably with forensic engineering approach. It's very important. I told about the examples, so let us run through quickly. And okay, it is mandatory to select the most appropriate NDT. If you have some tooth pain and go for a CPT test of stomach, it doesn't make any sense. So you have to identify what was the observation on that concrete structure, and accordingly select proper NDT and go for that proper NDT, so that you can go close to the root cause analysis, right? That's what I've been telling, with specific bearing of, okay, every NDT result, comprehensive analysis, it will lead us to the right rehabilitation scheme. If porosity was more, then we have to think more, focus more about the grouting, injection grouting, because core has to be strengthened. If reinforcement was bad, if carbonation was there, if chloride was there. Have you heard of flushing of concrete member? Yes. If the contaminants have gone and settled inside the concrete mass, it has to be flushed, and the contaminants have to be taken out. I recently completed, maybe in the month of October, I recently completed a project wherein I flushed the concrete section, and the mass which came out of the other side of the nozzle, when it was tested in laboratory, the people were shocked to see that the chemical which was being manufactured in the industry, that was a part of that extraction. So flushing is important. So I mean, every NDT has bearing on ultimate designing the rehabilitation scheme. Don't be shocked to see these structures. These structure pictures are of real structures. They are not animated structures. The one on your left is a structure, is one of the 8 columns supporting a boiler on top, which is having a load of 40 tons static load, not dynamic load, but static load. But you can see the condition of concrete, and still it was surviving, and boiler was running when I visited this area. So I just want to tell you to what extent concrete can get damaged, deteriorated, and still the great concrete stands still. It still functions. I do not know where this cover concrete is tending to go, where it has decided to go. I do not know that. The one on the round tank which you see, and the traces which you see of orange traces, they are not any effluent or any chemical. They are all traces of rusted reinforcement area. So the rust of reinforcement has come out of this. This is rust. This is not chemical. Now this is the area. This is the kiln in a cement plant, and you can see reinforcement. You can see reinforcement exposed, and this is having. When I went there to see this, the temperature itself was about 140 degrees centigrade. So this temperature can cause this type of effects. The skin has gone, it has spoiled, and reinforcement corrosion, you can see to what extent reinforcement is corroded. This mass, you can remember this picture. This is a picture of in cabin industry, wherein on top of this beam, the filter of ammonium nitrate was running, and you will be surprised to know ammonium nitrate has got more corrosive value than explosive value. You can remember this picture. Its reference will be made later on. Let's see. There are some criteria for structural rehab scheme design. Fresh mass must be supported, should have identical properties as mother mass, so that the thermal behavior and density, they go at par with each other. New mass should not become a burden. It should be supported right from the foundation. High density material is fine, but then it should not become a stressful on the mother mass. That is very important. High pressure applications are good. There we go for high injection grouting, high pressure applications, but it should not be. It should be moderate. It should be balanced such that not only the material goes inside up to the crevices, but then it should not be excessive pressure so that crevices would increase. So that should be very meticulously calculated area, right? Then physical properties of materials, properties, chemical compatibility, exothermic reaction, pot life of the material, consumption pattern should be decided before we select the material for rehabilitation. Availability of material should be ensured. Material must be available. We design a scheme for about maybe consuming 1,000 bags of material, but then one fine day we find that we are left 400 bags are left, and then they will take some time to come, so that the time factor will play its own part to further get down the rehab scheme. The protective, the rehabilitated surface must be protected. Though we have done the operation of rehabilitation, but it must be protected. It can be sacrificial coating, but then it must be protected, as we said. So we saw in the earlier part of the thing. Finally, selected material should have no accident. Environmentally, it should be good. No environment hazard should be there. There are some material they create harmful condition, so they must be very carefully handled. Now, this is very important. Rehabilitation is very important activity wherein we have to see that if you are rehabilitating only one or two members, other structural members are not affected. That is very important, because while doing one thing, we recently came across right in Dubai. We recently came across one area wherein we're trying to rehabilitate three members, but then its resulting effect was coming on the fifth member, and fifth member was failing in the structural design. So that had to be addressed first before addressing these three members to take it for rehab. The demolition should not generate any environmental imbalance. That is very important. Economy ultimately comes down to economy. Economy cannot be ignored. So case studies, as I told you, I am from industrial background. I'll go with like a case study of concrete structure, which was. Let us start first with the steel structure. These are the steel structures exposed in industry. This is all what you see white is all deposit of corrosive chemicals, and this is the steel member. I do not know whether it was ISMB 250 or MC 150 or and so many layers. You can see how much corrosion has taken place. Just see. I just wanted to show that. How do you expect this member to carry all these loads against a dynamic load and static load and wind pressure, and how can you expect these things? I'm just bringing to your notice that these things can happen in industry. These things fortunately do not happen in conventional domestic area, but then this happens in industry. This structure has lost its buildability. We checked the buildability and it had gone, so we had to go for some different method to rehabilitate the structure and recoup the to bring back the load carrying capacity. Where do you see the structure going? I do not know whether this will take any more load. Again, same members. You can see to what extent the skin has started eroding. Same thing. Now, this is the structure. This structure is under rehabilitation. What was done? This is a structure which I handled this structure, so I'm sharing with you. What was done? That we identified. We didn't want to bring down the structure and erect new. So we identified what were the lost parameters. Re-engineering was done. Reverse engineering was done. And the members which had reduced its thickness or reduced its parameters, where the structure was designed with those less parameters, and then what was required to be recouped, that was that was identified, and those spots were identified. You can see some plate has been placed here, some plate has been placed here, one member has been placed here. So we just augmented those members with to make up the lost parameters, and that is where the structure was rehabilitated. This is called steel structure rehabilitation. What we did, what I said, the same thing has been told here. And now we go to concrete structure. Put your hands on your heart so that you should not feel bad. One structure got severe, was badly damaged under severe explosion. A 10 metric ton ammonium nitrate tanker got blasted in an industry somewhere in the year 2003, sorry. And that is where one lime storage structure was very, very badly affected. I'm showing the case study of that structure. The structure was severely damaged. Okay. Okay, I'm sorry, I'm not able to show the photographs. Probably the slideshow is ma'am, can you show these photographs? Can you run this slideshow?
Go to the presentation mode, maybe Chirag, because maybe that's why we can't see them. They show on the original one.
Okay,
You want to stop sharing and share again the PowerPoint?
I'll stop sharing here, and I'll again start sharing from here. Okay.
So share the
Give me 1
PowerPoint.
minute.
Yeah, okay, perfect. Now you can go to slide 100.
Yeah, of course. I'm doing it very quickly so that.
Perfect, yeah.
The slides are. Yeah. This was the silo. This was the lime storage structure, which was very badly damaged during the explosion. And the members were bad, and the members had got the top member had gone, totally gone. So what we did, we the whole silo was a portal structure. The portal structure was then converted to simply supported structure, and we erected the steel trusses to make it simply supported. In the process, the structure became, slenderness ratio has increased. So long columns effect was there. That was compensated with by creating one more grid of columns. This is the one more grid of columns, and this is the trusses erected. Okay. So I'm sorry I could not show the complete thing, but I'll share that thing Imam with you so that you can share with whosoever want that. Now second classic example is pile. You can see these piles. Can you see how badly it has been damaged? It's very badly damaged. It is in a chemical zone area, wherein that high tide, low tide in between area, slushy area. Can see the extent of damage which pile has suffered. Just see the hole on pile. You can see what it must have undergone. Just see the condition. So here it's a classic example. What we did, the rehab scheme was such that we had designed shuttering, but shuttering was to be left permanently over there. It was a two-half shuttering. It was two-half material of FRP. FRP was again designed with polyester as a makeup thing and vinyl ester as a top coat. And then the things where micro concrete was pumped from bottom as we do in piles and was filled up to top, and the pile, the shuttering was left there so that the external effect of salinity did not affect the piles. So that was one of the classic things. And then we also managed such that reinforcement corrosion also could be maintained, could be monitored from top. So these are all the steps which we did. I'm sorry I could not show the all photographs. Okay, FRP was there. Special care was taken to stop, and okay. General points to take care. Inbuilt resistance of corrosion mitigation of concrete can be created with following measures. Construction by following standard construction practices. Let us construct only with standard construction practices. We should blindly and strictly follow them. Any deviation can lead to concrete corrosion. Treatment of construction joints and expansion joints is of utmost care. We may have to leave construction joints. Yes, we cannot go for 1.2 more than 1.2 meter high build up in column and expansion joint, but they should be treated very properly. For water retaining structures, we must go for water stoppers as to be given at a regular interval. Functionality of structure must be maintained because structure if it is a recreation structure, then it cannot be converted to any other thing. So otherwise, loading pattern and other things also will change. Structures with special services like water retaining, as I said earlier, the water stoppers and mass, then machinery, mass concrete must be constructed with following guidelines provided by global codes. If it is mass concrete, we have to compensate for heat of hydration. If it is machinery foundation, we have to go for the fineness, we have to go for the dampness of the foundation, so that dampening effect will take care of vibrations. So all these things have to be taken care. Otherwise, concrete has to deteriorate. Construction chemicals have to be used very carefully, because most of the time there might be some adverse effect. There may be some side effect of those chemical, and all effects must be seen very carefully before selecting a construction chemical for a particular functionality. For root cause must be identified, concrete corrosion. Just a cosmetic treatment won't work. Just there was a crack, just put some paste, some cement paste and crack seal. No, that will not work. The most appropriate test must be carried out for NDT. Practicing every concrete member, protecting member is most important. It is undisputed fact that following standard condition practices automatically mitigate the concrete corrosion. We have to follow the standard practices. We cannot deviate from those practices. We cannot take it, oh, that is my experience, nothing will happen, let's go for the complacency. It will not work here. This is there my details. I am just a phone call away. Just you can contact me anytime for any of the problems you have. And at the end, this is where I want to conclude my talk with this particular note. Concrete is a delicate material. It's a live material, delicate material. Handle it with love and care. That's where I end. Thank you very much, Aistakti, Imam ma'am, and everybody to give me opportunity to share my thoughts. If you have any questions, I'm there. Welcome.
Thank you very much, Engineer Chirag. That was really a very interesting talk with lots of examples and deep dive into lots of things around testing and so on. If we can maybe, if you stop sharing your screen, Chirag, we can spend 5 minutes if you like. I can share the photos and you can add your comments, because those were missed. I'll try to show my screen. This was, I think, the example that you wanted to explore.
Yeah.
Yeah. Do you want to add anything?
This was the first picture which I wanted to show, that this was the explosion. When explosion took place, on the very next day, this was the condition of that particular structure. Right. Yeah. Okay. And the other photos, do you want to revisit any examples? Yes. These were the pictures of during structural rehabilitation. Yeah. Can you go up? Can you go slightly up? In steel structure area, I wanted to show that microstructure of. Can you slightly go up? Maybe still. Yeah. Now this is the I want to tell all my delegates. This is the microstructure analysis, microstructure of a steel member which is having no contamination, having no crevices, and it's a sound structure. But the next one, can you please go to the next one? This is having crevices. You can see these white things are crevices, and these things, when they were again extrapolated, when they were again flushed out, and these are contaminants. In 8 mm thick MS plate, can you imagine that corrosion created crevices, and corrosion created a way for these contaminants to enter in that metal section? Metal section, not a concrete section. Metal section is highly impervious as compared to concrete section, but then still it happened. So this is what I wanted to show, that these things are, but I tell you one thing, that it is possible now to find out why, I mean, what's happening to metal section? Even metal can be taken to NDTs, and they can be taken, we can find out what's happening inside the concrete or steel mass to know and to design the rehab scheme. That's what I wanted to tell you.
Sure, thank you very much. Is there anything else you'd like to revisit?
That's okay. That's okay. I mean, that's fine.
I'll stop sharing. Thank you. And I'll go to the questions. Okay. We've got a question from Ahmed Tawfiq, Chirag.
Yeah.
For existing elements, what is the best way to protect concrete from corrosion during repair strengths? And then let's start with this one. So for existing elements, what's the best way to protect concrete from corrosion?
To protect concrete from corrosion, basically, as I said, 4 things: alkalinity, reinforcement corrosion, chloride resistance, and zero porosity, near zero porosity. These are the 4 essential, fundamental, essential things which gives internal immunity, internal strength to concrete, which will take us to this zone wherein it will not easily get corroded. If it gets corroded, if it still tends to corrode or shows signs for corrosion, in that case, the proper protective coatings are required. Coatings, maybe injection treatment also may be required, or coatings are required. But then again, there is no copy paste over here. Every case has to be seen independently, individually, and the conditions causing corrosion must be identified, and then only it can be seen that how best treatment can be provided.
Right, thank you. And another good question from Ahmed as well. For tents with anchor bolts embedded inside RC slabs, what is the best practice to protect anchor bolts from corrosion?
Anchor bolts, definitely. Anchor bolts, yes, definitely. They can get corroded, but anchor bolts have got different function to do. Anchor bolts are to be always covered with the non-shrink grout, so that the shrinkage factor which causes the crack formation for the contaminants to enter and corrode the anchor bolts. So the shrinkage compensating chemicals, those grouts must be put around the anchor bolts for preventing them from getting corroded. Non-shrink grout is most important. We cannot live with the normal conventional grouts. Maybe if functionality permits, epoxy or epoxy-based grouts are also preferred in that area. But then epoxy grout has to be carefully designed. They are good for holding the anchor bolts in the right thing and preventing them from corrosion. But then non-shrink material around them will definitely protect them from getting corroded.
Sure, thank you. Another question coming from YouTube from Hemant Kaur. We started using replacement cementitious material, for example, fly ash, GGBS, microsilica in recent years, yeah? Did you come across corrosion problem in concrete with fly ash, GGBS, etc.?
Fly ash, GGBS, even rice husks, even there are many other things coming up like zero cement concrete, more of lime content, and all those things are there. But then fly ash, what is the source of fly ash? Fly ash ultimately comes out of coal. It's a bottom ash hopper, bottom hopper ash. So from boiler steam generation plant, what was the source of coal? If I have seen where I was working, I have seen fly ash also differed with this change in source of coal. So fly ash properties have to be seen. Few fly ash material have got more of alumina, but few things do also contain more of sulfur. And if the sulfur content is there, then corrosion will take place. Fly ash, as a fly ash, generally speaking, doesn't. I mean, it's a pozol. So pozzolana helps to reduce the heat of hydration. But then corrosion protection is not essentially connected with the use of fly ash or GGBS. GGBS, of course, is picking up, but then GGBS has more potential for corrosion protection. But then fly ash, it depends on the source of fly ash for going ahead with as a protective corrosion protection domain.
Okay. Thank you, Chirag. A question from Dr. Shapoor Merkar. Is it possible to define a design life after the rehabilitation measures?
A design like? Can you please repeat the first time?
Is it possible to define a design life after you complete rehabilitation measures? So obviously you've got the original design life, but then when doing rehabilitation, is it possible to define?
That's a very good question. That's a very good question. I referred during my talk once that we have to design the structure rehabilitation depending on the life expectancy. If we want life expectancy in of 10 plus years, 15 plus years, then we can achieve that. But then there has to be regular maintenance. There has to be regular inspection, observation, and maintenance. What I have achieved in my career is 35 years life without any major maintenance. Maybe slight protective area, or maybe recouping of the protective coating at every 5 or 6 years, that's fine. But the basic structural element was protected from aggressive chemicals. Not this conventional salinity or not conventional residential area, but aggressive chemicals. I have seen life of 35 years. So it's possible to give life of 35 years, but then you have to design the scheme accordingly with good construction chemicals, with good practices, with good sequence of working. Yeah.
Sure, thank you. I think this is it. I can't see any more question coming up. Is there anything else anyone would like to add? Final chance. Of course, you will have Mr. Chirag available in the UAE to reach out in the future if you have any other questions. Okay, I see a question from Dr. Shapoor as well. Definition of any codes. Is there any codes that dictate or guide to comply with when it comes to rehabilitation, Chirag?
There is a Indian standard code for structural retrofit of seismic retrofit. There is a code for seismic retrofit, retrofit of structures against seismic attack. But then it's Indian code 1893. But then I do not know whether there is any ASTM or DIN code, or I do not know. But as far as I know, there is no code specifically for this thing which I spoke for last about half an hour or 1 hour. There is no specific code for that. As far as I know, but I'll try to find out, and if possible, I'll share with Madam so that she can share with you.
Thank you, that'd be great. Another question coming from Hemant Gaur. As a design engineer, should I recommend ACI third generation corrosion inhibiting admixture for highly corrosive environment?
Yeah, it is.
Okay.
It's a good option for corrosion inhibition. It should be properly done. Corrosion inhibition is done by so many areas. I mean, so many ways, in so many ways, like sacrificial anodes, like liquid addition to the matrix, or like brushable application. But it should be very specifically done. Should be carefully done. It is a result effective treatment. I have seen it in practice. It's a very good treatment. Even blending it with microconcrete also makes microconcrete quite corrosion inhibitant. Fine. But then it should be done very carefully and very precisely as per the manufacturer specification, because every treatment has got its own parameters.
Excellent. Thank you very much, Mr. Chirag. I don't see any more questions. I would like to thank you again for your contribution today. Any final comments?
I also would like to thank Ma'am Imam and ISTRUCT as a whole, the group as a whole, to give me an opportunity, because there are very few. Ma'am, you must have seen many of the presentations would cover E equal to MC square and X square plus B square and delta P, and all those things must be coming across. But there was no such thing in my presentation. It was all applied knowledge, amalgamation of inculcation of the applied knowledge, which I try to share. But these things are important. I would like to convey one message to these structural design people also, that concrete has got strength, concrete has got parameters, concrete has got, it's a versatile material. But when we design structural element, beam or column or slab or whatever functionality, we must take care of expected reinforcement corrosion, expected concrete corrosion, or down the line. Maybe if you are designing a member for 5 years, 6 years, 10 years, please expect reinforcement might corrode. There might be some contaminant left inside during the construction. You might have used some bad water, and chloride might have gone inside. Sand might have carried some chloride inside, and that chloride might get activated after 5 years, and then reinforcement corrosion may start. So you may not get 16 mm diameter rod at the end of 6th year. So these allowances have to be taken care. This is more relevant in seismic zone areas, wherein we have designed a structure without ductility provision and seismic zone area, and in that case, when reinforcement corrosion takes place or when concrete corrosion takes place, in that case it becomes difficult. You do not have any clue why structure failed, even though it was designed with very high safety factor and very, very good parameters. So these things, applied knowledge, whatever I try to share, should also go into design softwares or design efforts to see the structure down the line after 5 years, 6 years, 10 years, and make some allowance for corrosion, make some allowance for concrete and steel corrosion.
Of course, yeah, sure, Dr. Engineer Chirag, and probably this gives us also an appreciation of the importance of proactive maintenance and regular inspection, so we don't get to a point of no going back or spending loads of money to fix things. Yeah. Okay. Thanks again. Thank you all for joining us tonight. See you soon on our next CPD then.
Thank you. Thank you so much. And I'm available. I've given my details. I'm available for any question, for any sort of advice. You're most welcome. Bye-bye.
Bye. Thank you.